In this question, we're asked, what is the static friction coefficient required between the wheels and the track for a vehicle to safely navigate a level turn with a radius of 80 meters at a speed of 90 kilometers an hour? For circular motion problems like this, you need a centripetal force. The formula for that looks like this, where centripetal force is equal to mass times velocity squared divided by the radius. Given we're told the vehicle is making a level turn, the centripetal force in this scenario is supplied entirely by static friction. The force of friction is equal to the coefficient of static friction times the normal force, which is mass times gravity, and we'll assume gravity to be 9.8 meters per second. For the car to just barely slip, the maximum static friction must be at least equal to the required centripetal force. So we'll set our two equations equal to each other, giving us the coefficient of static friction times the normal force, which we will rewrite as mass times gravity, is equal to the mass times velocity squared divided by the radius. We can then divide both sides by mass and cancel them out. So when we divide that, we get the coefficient of static friction times gravity is equal to velocity squared divided by r. And we can then divide both sides by gravity, which gives us the coefficient of static friction equals velocity squared divided by the radius times gravity. We're told that the speed of the car is 90 kilometers an hour, and we need to convert this to meters per second. So we can take 90,000 meters and divide that by the seconds in an hour, 3,600, and that will give us 25 meters per second. So now we can plug all of our numbers into our equation here, and that will give us the coefficient of static friction is equal to 25 squared divided by 80 times 9.8. That gives us 625 over 784, which is about equal to 0.7971, or 0.8, making our coefficient of static friction 0.8.